The Pythagorean theorem is the study of right triangles. Though it can be used in other triangles as well, or to help us talk about other triangles, it particularly looks at the right triangle. Let's take a look for a second at a right triangle. A right triangle. We know it's a right triangle because I've drawn the little box in the corner. Without that box, you don't know it's a right triangle. What do you know about right triangles? What's the biggest thing you know about right triangles?
They have a 90-degree angle.
They have a 90-degree angle. A right triangle will always have a 90-degree angle. That's what the box tells us. If the box is missing, it could be 89.9999999999999. It's not going to be a right triangle. It could be 90.0000000000001. That's not a right triangle. It must be exactly 90 degrees. The two sides that make up the right triangle, so this side and this side, they have special names. Anyone know what those names are called? What those sides are called?
The base and the spine.
Nope.
The floor and the wall.
Nope.
They mentioned this in 6th grade.
They are called legs. And we're going to call this leg A, and we're going to call this leg B. The side that is opposite the right angle, anyone know what that's called? It's called the hypotenuse. It's called the hypotenuse. So we have two legs and a hypotenuse, and those are what makes up the sides of the right triangle. We'll call the hypotenuse C, and you'll understand later why I'm using the letter C. Now, the Pythagorean theorem says the following. The sum of the squares of the lengths of the legs equals the square of the length of the hypotenuse. The sum of the squares of the lengths of the legs equals the square of the length of the hypotenuse. And that is the true Pythagorean theorem. Let's talk a little bit about what this is actually saying and what this means. The reason we use that as the Pythagorean theorem and not a simplified version, which I will show you now, is because there are ways I could twist the Pythagorean theorem around that won't work unless you know the true theorem itself. But let's say I draw a right triangle, poorly drawn right triangle, and I label the legs A and B, and the hypotenuse is C. What the Pythagorean theorem tells us, it says, listen to what it says, the sum of the squares of the lengths of the legs. Okay? Well, the lengths of the legs are A and B. The square of the legs is A squared and B squared, and the sum of those is A and B. Equals the square of the hypotenuse, which is C squared. And uniquely, Pythagoras played around with this a lot. By the way, in a very basic sense, people, if I said to you, what's the Pythagorean theorem? A lot of people respond, oh, it's A squared plus B squared equals C squared. And that sounds great, but what if I made this B and this C? Would that be true then? wouldn't be true. So you got to be careful in how you read the triangle and what I call B and C or A and C or whatever. I can mix up those letters to throw you off. So you've got to know that which are the legs and which is the hypotenuse. That's the simplified version, yeah. Usually what we say is a squared plus b squared equals c squared if a are the legs and a and b are the legs and c is the hypotenuse. That way it's a little bit more detailed, but if you really want it, we write it the other way. When Pythagoras did this, Pythagoras looked at a specific triangle. And it was unique, the one he looked at. He looked at a triangle that had sides of 3 and 4 and had a hypotenuse of 5. And what he noticed then was if he drew squares off of the sides of the triangle, if he drew squares off of each side of the triangle, this is what he noticed with a very specific triangle, which if he took the side that had a 3 on it, and he put a square that had a side of 3 against it, what was the area of that square? It was 9. If you took the side of 4 and found the area of the square that was up against it, what is the area? 16. And if you took the side of 5 and found the area, what do you get? 25. And what he noticed was that 9 plus 16 equals 25. Now, cool about this was that it doesn't only work with squares. He also did it with semicircles. And he found that the area of a semicircle that had a radius of 1.5 and an area of the square that had a semicircle that had a radius of 2 and one that had a radius of 2.5 also worked out the same way. So it worked out that the squares were where it came from. Let's look at this for a second. If I gave you the following 3 lengths of the sides, do these 3 sides make a right triangle? Let's not do that one yet. Let's do 5, 12, 13. Do those make a right triangle? And let's do 3, 7, 5. Do those make a right triangle? And by the way, one of the questions is, how do I know which of those 3 sides is the hypotenuse?
The largest?
The hypotenuse will always be the largest number. So in the first one, I gave you 5, 12, 13. What's the hypotenuse?
13.
In the other one, 3, 7, 5, what's the hypotenuse?
7.
Well, I shouldn't say what is the hypotenuse. It's supposedly what would be the hypotenuse. 7. Okay. So pause the recording and figure out, do they make a right triangle? All right. Let's see if you got these right. If you did, you would have looked at 5, 12, 13, and you would have asked, is 5 squared plus 12 squared equal to 13 squared? Is it?
Yes.
Yes, because 25 plus 144 equals 169. So 169 equals 169. So this is, in fact, a right triangle. How about 3, 7, and 5?
No.
Because here I'm looking at 3 squared plus 5 squared equals 7 squared. What's 3 squared?
9.
What's 5 squared?
25.
What's 7 squared?
49.
So I'm looking, what's 9 plus 25?
34.
Does 34 equal 49?
No.
So this is not a right triangle, because it does not work in the Pythagorean theorem. Now, I want these because sometimes we get some interesting things that happen. For example, 1, 1, square root of 2. And I will tell you square root of 2 is the largest number there. Does that make a right triangle? How many people say yes? How many people say no? Majority are saying no. Let's take a look. If I did this right, I would go 1 squared plus 1 squared equals the square root of 2 squared, right? What's 1 squared?
1.
What's 1 squared?
1.
What's the square root of 2 squared? 2. And 1 plus 1 is 2. 2 equals 2, so this is a right triangle. When you square a square root, the square and the square root cancel each other out. So it just becomes the number under the square root. All right. Now, here is the other bigger question. Watch this. Here is a right triangle. One side is 6. One leg is 6, I should say. The other leg is 8. How big is the hypotenuse? How long is the hypotenuse? I want you to pause the recording and I want you to see if you could figure this out. So, if you did this correctly, you would have used the Pythagorean theorem and set it up with the Pythagorean theorem and said 6 squared plus 8 squared equals c squared. The sum of the squares of the length of the legs equals the square of the hypotenuse. Now, I can figure out 6 squared easily. 6 squared is 36. I can figure out 8 squared, that's 64. And c squared, well, that's c squared. I can do 36 plus 64, that's 100, and that equals c squared. But the fact is, I don't want c squared. I want c. So how can I get c squared and make it c? Take the square root. But if I take the square root of one side, I better take the square root of the other side. The square root of 100 is 10, and the square root of c squared is c. So c equals 10. Try this one. Now, what I will tell you is that not every answer comes out nicely. The nice answers are called Pythagorean triples. This is not that. So 3, 4, 5, 5, 12, 13, 6, 8, 10. Those are Pythagorean triples. But 1, 1 square root of 2 is not, because it's not 3 whole numbers. When you get an answer that's not a whole number, you can't do the Pythagorean theorem the same way. You can, but you can't get an answer, and you're not using a calculator. I want the answers in simplest radical form. That means I want you to simplify the square root. Let me show you what I mean by that. Let's say I give you 4, 6, and c. I want to know what is c. We're going to work this one together. So, I would go, what would I do? 4 squared plus 6 squared equals c squared. What's 4 squared?
16.
No. It's a game you play in elementary school.
Oh.
Okay.
That's 4 squared, not 4 squared.
What is 6 squared?
36.
36. And that equals c squared. What's 16 plus 36? 52 equals c squared. Okay? What do I do next? Square root of both sides. I know the square root of c squared is c. But the square root of 52, I wonder if I could simplify that, because 52 is definitely not a perfect square, right? So let's see, 52. What goes into 52? I know 2 does, and 2 goes into that 26 times, and 2 goes into 26, 13. So this is the square root of 2 times 13. There's a pair of 2's. So C is actually equal to 2 root 13. And that's in simplest radical form. Now, take a look at this problem. And tell me how you would do it. I want you to do this. 8b 12. Find b. Pause the recording and try to find b. Did you find b? I did. It's right there.
Yeah, it's right there.
Okay, kid. Okay. So, if I wanted to find b, what would I set up as my Pythagorean theorem? Anybody? 8 squared plus b squared equals 12 squared. Notice it's set up a little bit differently. The b does not go on the other side of the equal sign because it's a leg. 8 and b are the legs, so I got to put those together. Okay, what's 8 squared? 64. What's b squared?
B squared.
What's 12 squared? 144. What do I do next?
Just subtract.
Subtract 64 from both sides. And those cancel, so I get b squared equals 80. Now what do I do? Square root of both sides. So let's see, 80 is going to be, that's 8 and 10. 8 is 4 and 2, which is 2 and 2. 10 is 2 and 5. And by the way, I can look at my square root just from my factor tree. Pair of 2's and a 5. So I get 4 root 5. B is equal to 4 root 5. How many people got that? Awesome. Great. So that is how we use the Pythagorean theorem.